In this tutorial, we will see how to replace the single time estimates for project completion time with probabilistic estimates. The activity completion times given in the prior tutorial were what are called deterministic time estimates. That is, there was no possibility of variation. If an activity had a completion time of 2 days, then it always took 2 days regardless of what happened. Of course, we know that's not the case. For example, it might take 1 day for paint to dry on a hot, dry summer day, but it might take 5 days on a cold, rainy winter day. If we have an estimate of that variation, then we can make probabilistic estimates about how long it will take to complete the project. Note that we will see how to calculate the expected completion time and variance for the activities. However, performing the probabilistic estimates is beyond the scope of these tutorials. The way we will estimate the variation of the activities is to get 3 different time estimates for each activity. Please note that we are simplifying the math behind these estimates. What you will see here is what you will see in an introductory operations management textbook. However, a project management textbook would go into much more detail. The 3 time estimates are as follows. 1. Optimistic time. This is the completion time when everything goes right. Some textbooks use an A for this while others use T sub O. We will use A in this tutorial. 2. Pessimistic time. This is the completion time when everything goes wrong. In other words, it is the worst completion time. Some textbooks use a B for this while others use T sub P. We will use B in this tutorial. 3. Most likely time. This is the completion time that is most likely to be required. Some textbooks use an M for this while others use T sub M. We will use M in this tutorial. Using these 3 estimates, we will compute the expected completion time and variance for each activity in the project. The expected completion time for an activity is the optimistic time plus 4 times the most likely time plus a pessimistic time quantity divided by 6. Note that the 4 and 6 are constants in this formula. The activity variance is a pessimistic time minus the optimistic time quantity divided by 6, all squared. Note that the 6 is a constant. This is mathematically equivalent to the pessimistic time minus the optimistic time quantity squared, all divided by 36. Data for a simple project is shown on the screen. Compute the expected completion time and variance for each activity. The expected completion time for A is 1 plus 4 times 3 plus 4 quantity divided by 6 equals 2.83. In this tutorial, all answers are rounded to 2 decimal points. The variance is 4 minus 1 divided by 6 quantity squared equals 0.25. The expected completion time for activity B is 2 plus 4 times 5 plus 6 quantity divided by 6 equals 4.67. The variance is 6 minus 2 divided by 6 quantity squared equals 0.44. The expected completion time for activity C is 4.00 with a variance of 0.11. Note that activity D has the same value for all 3 time estimates. This would be an activity like shipping parts across country or waiting on a permit where no variability is expected. It has an expected completion time of 3.00 and 0 variance. The expected completion time for activity E is 8.33 with a variance of 0.44. The expected completion time for activity F is 6.33 with a variance of 0.44. Now here's an example for you to try. Data for a simple project is shown on the screen. Compute the expected completion time and variance for each activity.
Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made.
The solution to the problem is shown on the screen. To plan the project, we would use the expected completion time and plan the project just like we did in the prior tutorial. The sum of the times along the critical path would be the expected completion time for the project. Likewise, the sum of the variances along the critical path would be the project variance. Once you have the expected completion time and variance, you can use confidence intervals and hypothesis testing to make all kinds of statements regarding the project. These are left to a project management course. If this video helped you working operations management problems, please consider liking the video and subscribing to the channel.